Hello all, welcome back to Neuroscience Hub Editor's Special. Let us understand what is happening in science around the world. Big boost to pharma industry as Finance Minister Sikaram unveils schemes to promote research and development. Promoting research and innovation in pharmaceuticals, Finance Minister Nirmala Sikaram, while presenting the Union budget for 2023 in the Parliament, stated that new programs will be taken up to various centers of excellence to promote research and innovation in pharmaceuticals. She said the pharma industry will be encouraged to invest in research. Excuse mentioned that the pharmaceutical industry has been urging for incentives to promote R&D investments. We shall also encourage to invest in research and development, the finance minister said. Dedicated multidisciplinary courses for medical devices will be supported in existing institutions to ensure availability of skilled manpower for futuristic medical technologies, high-end manufacturing and research, she added. This groundbreaking biomaterial heals tissues from the inside out. The material can be injected intravenously and has potential application in heart attacks, brain injury and more. A new biomaterial that can be injected intravenously reduces inflammation in tissue and promotes cell and tissue repair. The biomaterial was tested and proven effective in treating tissue damage caused by heart attacks in both rodent and large animal models. Researchers also provided proof of concept in a rodent model that the biomaterial could be beneficial to patients with traumatic brain injury and pulmonary arterial hypertension. This biomaterial allows for treating damaged tissue from the inside out. It's a new approach to regenerative engineering. A study on the safety and efficacy of the biomaterial in human subjects could start within 1 to 2 years. Kreisman of University of San Diego added, the team which brings together bioengineers and physicians presented their findings in the December 29 issue of Nature Biomedical Engineering. New ice is like a snapshot of liquid water. Scientists have discovered a new form of ice that more closely resembles liquid water than any other and may hold the key to understanding this most famous of liquids. A collaboration between scientists at Cambridge and UCL has led to a discovery of a new form of ice that more closely resembles liquid water than any other and may hold the key to understanding this most famous of liquids. A new form of ice is amorphous. Unlike ordinary crystalline ice, where the molecules arrange themselves in a regular pattern, in amorphous ice, the molecules are in disorganized form that resembles a liquid. This team created a new form of amorphous ice in experiment and achieved an atomic scale model of it in computer simulation. The experiments used a technique called ball milling, which grinds crystalline ice into small particles using metal balls in a steel jar. Ball milling is regularly used to make amorphous materials, but it had never been applied to ice. Ultra-processed foods may be linked to increased risk of cancer. Higher consumption of heavily processed foods may be linked to an increased risk of developing and dying from cancer. An Imperial College London-led observational study suggests. Researchers from Imperial School of Public Health have produced the most comprehensive assessment to date of the association between processed foods and the risk of developing cancers. Ultra-processed foods are food items which have been heavily processed during their production, such as fizzy drinks, mass-produced packaged breads, many ready meals, and most breakfast cereals. Ultra-processed foods are often relatively cheap, convenient, and heavily marketed, often as healthy options. But these foods are also generally higher in salt, fat, sugar, and contain artificial additives. It is now well documented that they are linked with a range of poor health outcomes, including obesity, type 2 diabetes, and cardiovascular disease. Silver nanoparticles show promise in fighting antibiotic-resistant bacteria. In a new study, scientists with the University of Florida found that a combination of silver nanoparticles and antibiotics was effective against antibiotic-resistant bacteria. The researchers hope to turn this discovery into a viable treatment for some types of antibiotic-resistant infections. Antibiotic-resistant infections kill more than 1 million people globally each year. For centuries, silver has been known to have antimicrobial properties. However, silver nanoparticles, microscopic spheres of silver small enough to operate at the cellular level, represent a new frontier in using the precious metal to fight bacteria. The research team tested whether commercially available silver nanoparticles boost the power of antibiotics and enable these drugs to counter the very bacteria that have evolved to understand them. We found that the silver nanoparticles and a common class of broad spectrum antibiotics called aminoglycosides work together synergistically, said Daniel Sis, senior author of the study and assistant professor of University of Florida, Institute of Food and Agriculture Science, Department of Microbiology and Cell Science. That's all this week. Thank you so much. See you soon. Bye-bye.